Good morning. We are discussing the compounds of phenol. Last class we have discussed phenolphthalein, and the next compound is fluorescin. Second compound of phenol, that is fluorescin. Fluorescin. Okay, how fluorescin is preparing? Fluorescin is prepared by heating resorcinol with phthalic anhydride in the ratio 2:1. Resorcinol with phthalic anhydride in the ratio 2:1 in presence of anhydrous zinc chloride. That means resorcinol is prepared by heating resorcinol with phthalic anhydride in the ratio 2:1 in presence of anhydrous zinc chloride. Okay, so keep it in mind, heating resorcinol with phthalic anhydride. Okay, look at the reaction. So resorcinol is okay, here it is OH, and here also OH. You might have studied, this is resorcinol. What is resorcinol? What is that? Benzene 1,3-diol, which is known as resorcinol. So resorcinol. Okay, here we need 2 molecules of resorcinol. The second molecule OH. Okay, the second molecule, here it is OH, and here also OH. Okay, this is 2 moles of resorcinol with phthalic anhydride. What is the formula of phthalic anhydride? Look at it here. Here it is C double bond O, and here is O. Here also C double bond O. This is phthalic anhydride. This is resorcinol. Resorcinol means benzene 1,3-diol. Now look at it here. In presence of anhydrous ZnCl2, what will happen? You can see that here is one hydrogen, and here also a hydrogen is there. Okay, so what will happen? This molecule, one molecule of H2 will be eliminated. Then what will happen? This bond will join with this carbon, and this bond is joining with this carbon, and one molecule of water is eliminating. And you can see that here H and OH, here also H and OH. So what will eliminate? One more molecule of water, H and OH. And what will happen? This bond is joining with the oxygen. So what we get? The structure will become like this. Here it is OH, no change. And here you can see that here is O, and that is fused with the second ring. Okay, here is OH, clear. And here you can see that the water molecule is eliminated. So you get a structure like this. Okay. Here it is C, and here it is C double bond O, here it is O, and you can see that this bond is joining with this carbon atom. So here is a bond, and here also a bond. This is what is known as fluorescin. This is the structure of fluorescin. Once again, 2 moles of resorcinol. What do you mean by resorcinol? Benzene 1,3-diol. This is first molecule, and this is second molecule. And here you can see the phthalic anhydride. Here H2O molecule is eliminating, and here also here is OH, and here also OH. Here also H2O is eliminated. So here OH joining with this ring. Okay, and here there are 2 bonds with the 2 ring. This is the structure of fluorescin. Structure of fluorescin. Of course, this fluorescin, when dissolved in NaOH, aqueous NaOH, that is very important. When fluorescin dissolve in aqueous NaOH, it will develop greenish fluorescence. It will develop a greenish colored fluorescence, and this greenish colored fluorescence is very important for the detection of many diseases, blockage. That means if there is any block in the blood circulation from brain to different parts of the body, or from heart to different parts of the body, etc. So that means the fluorescin is very important for detecting many diseases. Now next is uses of fluorescin. Uses of fluorescein. First one is used as an absorption indicator. It is used as an indicator for titration of halide ions with silver nitrate. When we are doing the titration between halide ions and silver nitrate, we are using fluorescein as an indicator. This type of titration is known as argentometric titration. So first one is it is used as an indicator in argentometric titration. What do you mean by argentometric titration? Titration between halide ion and silver nitrate. Second one, sodium salt of fluorescein is used to study blood-brain barrier, that is BBB, and blood spinal cord barrier, BSCB. That means sodium salt of fluorescein. As I told you, when fluorescein is dissolved in NaOH, we get greenish fluorescence. This greenish fluorescence is used to study if there is any barrier between what is that blood and brain and blood and spinal cord, etc. Because when we inject this fluorescence or the fluorescein, we can study the path of that fluorescence is going, and if there is any obstacle, we can identify with the by analyzing the path of the fluorescence. Okay, so if there is any blockage is there between blood and brain, and blood circulation into brain and blood circulation into spinal cord, etc., we can identify with the use of this fluorescence. Okay. Third one, to monitor solute transportation into bone. The solute transportation into our bone, that also we can monitor using fluorescence. Next is for the diagnosis of corneal abrasions, ulcers, etc. The presence of the disease ulcer is there, or corneal abrasion is there, etc. can be detected by using this fluorescein. That means sodium salt of fluorescein, that is greenish fluorescence. By injecting that one, we can identify the presence of that diseases. Last one is dye for wool and silk. It is also used for dyeing wool, silk, etc. Okay, these are the uses of fluorescein. Okay, and okay, thank you. We continue with the next compound in the next video. Thank you.